Hey, so in this video I will demonstrate how you can use um, memory IP in Quartus. So for a design, it's very simple in my case because I only need to demonstrate it for you. So when I press a key 0, address pointer in memory will increment, and when you press key 1, address pointer in memory will decrement, and that's it. And then I will send this 8 address to the memory unit, and it will give me the data. So this data will be sent to the LEDs. So you go to tools and then IP catalog. Right now it's already open on the right pane of my screen. So you click into memory interfaces, then go for none of those actually. Let's see, let's go for RAM. So one port RAM is what I need right now. So I click that and let's create a RAM. So RAM stands for random access memory, and if you want to use a volatile non-volatile memory, then you have to use flash memory. So in my case it's fine, so I will use that. So the bit width of the data that you want to store is 8 bits. In my case it's 8 bits, but you can make it 7 or how many you want. Let's make it 4 for demo. And how many of those sized memories you want. So in my case my address is 256, or let's make it smaller, so it will be better to debug. So I'll make it 16. So 16 words, and each word is 4 bits, and that's pretty much it. That's all I need right now. So I press next, and then I can register this output one more, but I don't want to, so it's fine. So if I do that, data is available after the 2 clocks. If I remove this register, the data is available after 1 clock. But if you enable it, probably it should be able to work on faster clock. But for me, I don't care. So data is there. Next, I go there. Now this, you can read the description what this is doing. So right now I don't care. So I just click don't care. Next, I can initialize my memory on power up. Now I can do that. I can click yes, and I can browse the file, which I don't have right now. So it could be in hex or MIF format, and it will initialize. So it will actually copy this memory into programming file, and once you program, this data will be already available on startup. But I can't do this right now because I don't have a memory initialization file ready, but I will show you how to generate this kind of file, and later when you generate it by yourself, when you generate this IP by yourself, then you can specify this MIF file or hex file. But for now I will just leave it blank. And this cool thing also, I will mark this is optional. This allows you to view memory online, but you can skip it of course, but I like it, so I will make it available so we can observe the data content live. So name of this should be something, so let's call live. So I will click next, then next, and I usually prefer to don't generate black box because I don't need to. I can even skip that, so what's necessary is generated and you cannot skip that part, but this gives you the instantiation template. So I usually click this. Okay, let's click both of them. Next, you finish and you click yes, and here if you go to files, this RAM is there. So second one was not template, wasn't generated, but black box got generated, but that's fine. So right now you see this is the input and outputs of this module. So I will copy this in my design to instantiate it. So I will copy this there and comment out. And next I will write my instantiation. So name of the module is RAM. I will call instance RAM1. Then first thing I have to give this module is the address. So as I remember, I made address, I made 16 slots of memory. So I will decrease this to 30, and I will send address to the address. I will send address first, then I have to send the clock. This is a clock signal. Then I have to send the data input if I want to write something into this memory. So I will actually send switches. Yeah, I will send switches. So I will write switch values there. Next, I will send something like enable signal for write. So let's make let's do it in following manner. Let's send this directly there. I think it shouldn't be a problem. So whenever I press Q1, enable signal for memory will be active, so it will write switch value into this address. And finally I need the data. So data is already 4 bits, so I will put it there. Data. So what's going on there is whenever I press key 0, address is changed, and whenever and address is changed, then new data is sent to me from memory or after 1 clock. And whenever I press Q1, write enable should be sent to the memory, and switch values should be saved into this address of the memory. And I guess that's all, except since data is now 3 to 0, I will make this equal to 3 to 0, and that should be all. Now let's wait for compilation. Okay, we had some error, so let's investigate what kind of error we had there. Okay, I forgot this. One thing I have to emphasize is this is RAM, so we are programming right now RAM. So if I change something in the RAM, then I power off and then I power on again, my updated data will not be saved on my FPGA chip, but instead initial data will be there. So the compile is complete, so let's program the device. So this is already programmed. Next, what we do is you remember I marked one check mark in IP creation stage, and I called something like live. So I will first demonstrate how that is useful. So I go there in tools and in system memory content editor. So I click that. Okay, and I have to program it from here also. Not from here also, but from here only. So then this module is working. So this is selected, then I press this. Okay, so now it is programmed, I think. So next, you see this live, I press this guy and I press update acquisition of live content from FPGA chip to here. So right now it's all zeros. If I select let's say values 3 on switches, so I will do it here but you won't be able to see it, but trust me, I selected values 3 in switches, and next I will press Q1. I think Q1 should be the key that is saving. Yes, so it's Q1. So I press Q1, then I press key 0, so I move to next address and I press Q1 again. So right now 3 and 3 should be saved into memory addresses 0 and 1. So I click this again. Yeah, but nothing yet. So let's move forward. Okay, still it doesn't work, and nothing is on LEDs. So anyway, this didn't work because I think I have the mistake here. So probably this is the mistake. This write enable is not working somehow, but it's fine. So you have the point, so I'm pretty sure you will make it work. But next we can proceed with updating memory from here directly. So I press 1 here, 1 1 1 or 3. So right now if I press this, it will update memory on FPGA from here, so from my computer, so like that. And currently LEDs are lit, so that's because probably okay, let's check how on which address we are at currently. So LEDs are still 3. They are still 3. Again. Okay, this is the one. So let's make it 5. No, this one was. I will do that. So right now it's showing me the value 5. So currently this is the address. If I press key 0, now it's showing me 4. So key 0 works. So somehow Q1 is not working. So it's not giving, it's not sending the right signal into memory. And I found the problem. The problem is I forgot to add my switches there. So switch should be there as an input. So that is 3 0 and switches. Now it will work, but I'm lazy to compile this design because I'm pretty sure it will work. So this is the way you update the memory online, and you receive data from memory online to Quartus and from Quartus. And one thing I promised is I will show you how to generate the MIF file so you can have initial data. So you right click there and you export data to file. So I tested how hex is actually written, but I think there was a problem there, so I went with memory initialization file template because that was the one that worked for me. So I will generate both of them right now. I will generate hex also, and let's go to this location. So our exported files were MIF. So let's check this. So this is how it looks like. This is our comments. So you specify the bit width of the memory words, then how many memories do you have, in what format the address is written, then in what format the data is written, and the values of it. So you see this is pretty much the same that was in this in this window. So you can generate this kind of initialization files from Python or something else. It's easy as hell. So you can write it in longer version. So you can write 00 like that, and so on. So we can make it like that. So this will work. Here I'm specifying on each address what is the value I want to have, and in this range what are the values I want to have, and that's it. It's pretty straightforward. Now regarding the hex, yeah, as I mentioned, I tried to generate, I tried to populate the memory from hex, but somehow it didn't work, so I gave up because I don't care. This works still, and it's pretty understandable. So yeah, it shouldn't be a problem there. So apparently these are the values. You see, this 3 is the value, 5 is the value, this is, I don't know what it is, some pointer to something, which really I don't care. Anyway, but if you have time, you can analyze that and write your analysis in comments, so it will be useful for somebody else. So that's all with memory. And it's I think you can agree it's pretty easy to use this kind of memory.